building ML apps, but you don't know the way how to deploy them. You don't know how you're going to show them to the world. And all those apps are just stuck there into your local machine. How can you get those apps as a web app into the market? So today in this video, we're going to see exactly that. I hope you guys enjoy this video and also gain some knowledge. This is Atharva from Pi Analytics. Let's go. The model we are going to use, that is a simple SVC model, I guess. For that, we're just going to use an SVC model. You can use your neural networks also. What you're going to learn is Streamlit. What Streamlit is it allows you, it enables you to make your models, like your machine learning models, and the model we are going to use, that is simple SVC model, I guess. For that, we're just going to use an SVC model. You can use your neural networks also. What you're going to learn is Streamlit. What Streamlit is, it allows you, it enables you to make your models, like your machine learning models, and show them as a web app to the world or to your local machine. It depends on you. You can also upload and deploy those models to the Streamlit community gallery, and that will be visible to the world as well as most of the, search engines. Even if you search your app with a search engine like Google or Bing, it will get searched and it will show you the results. Depends on the URL though. Okay, so without further ado, let's get into it. Now, firstly, what we will do, we will get familiar with the ML model that we are going to work with. Okay, so as you can see, here's the file tree. Okay, we have the notebook, then we will build an app here. I have my GitHub Copilot, but doesn't matter. Okay, and diabetes.csv is the CSV file, the dataset that we are going to use for this video. Okay, this app works on the SVM model, as I said, in the backend. It uses scikit-learn matrix to get an accuracy score, and again NumPy pandas, that is the basic thing. Okay, so let's get familiar with the notebook itself. Let's first import all the libraries and let's import the dataset. Okay, so I have done this on the sure thing. Okay, so what happened there was I had trained this model into the Google Colab notebook, so that's why that content path was there. Okay, so let's work with the app itself. I'll just close this file for now, and let's check the head. As you can see, we have the some columns as pregnancies and glucose and blood pressure. We have other columns like ages and insulin also. What will happen? Okay, once we get the shape of this dataset, what will happen? As you can see, there are 9 columns and 768 rows, or you can say records of the persons having diabetes or not having diabetes. Okay, so let's work with this dataset. Let's get some insights. As you can see, these are some counts. There are no null values. I have taken a simple dataset, a very basic dataset. You can work with your dataset as well. The main thing you are going to focus in this video is Streamlit, not the notebook itself. Okay, so after describing, I have already done this analysis and all, so that's why I'll just move forward. We have just splitted the dataset, separating the labels and data itself, and then printing the X and printing the Y, then splitting the data into as a training set as well as a testing set, while stratifying the Y, and lastly keeping the test set as 20%. Okay, so let's get the shapes now. As you can see, the shapes are there. Now We are going to train a model, an SVC model. Okay, we are going to like fit it to the classifier, the data. Okay, and lastly we will predict. The predict function is so simple here. Depending on your model, your predict function might change, might not change, depends on. Okay, so let's print the accuracy. As you can see, the 0.77 identifies as the 77% accuracy, 77.27 to be precise. And in my opinion, your neural networks, when you're like training your neural networks, do learn to accelerate them using the GPUs, because your training time will be shortened and you will get more time to develop a web app in order to showcase it to the world. So that's the real motive of this video. Okay, so this is the prediction system. Now this is where we are going to focus more, because this system we are going to build again in this diabetic prediction web app.py, like the web app Python file. Okay, what we are going to do here, we are going to take an input array, it is a tuple, as input data. We are going to convert it to the numpy array using as array function of numpy. Okay, and lastly we are going to reshape it to be a column, and then again call the predict function onto our onto our model, and then lastly we will print the prediction, and we will use Streamlit in order to showcase it to the people that use it. What Streamlit does is it provides a UI for your app, and that's it. That's the real intuition behind using Streamlit. Okay, as you can see, the person is diabetic, it says. Now here comes the real part. After training your model, do save them using pickle or any other method that you're going to use. For example, for TensorFlow, you just use the save model function, and for PyTorch you might use the PTH format of the, I'm not more familiar, but I think it's PTH. I think I'm right here. Yeah. Okay, so it might be PTH or anything else, doesn't matter. Do save that model, and we are going to use that model into our web app. I hope you understand. And now let's go. Let's save our model using pickle this time, because we are using scikit-learn here, and usually the scikit-learn models are saved using pickle. Again, for TensorFlow, the save model function, and again for PyTorch, the .pth format file. That file you're going to use, and depending on your practices, we are going to make changes in the web app also, as well as the prediction function. Okay, we have verified that the function is done, and the loaded model, that is, the model is being loaded correctly, so that will be good for us. Okay, as you can see, the person is diabetic, the same prediction as before, and so it is verified. Now let's move on to the real part. What real part initiates is we're going to use this model and make a Streamlit app. What Streamlit does, again, I'm telling you the third time, it again provides a UI for the user to interact with your app. And lastly, yeah, that's it. And let me just disable my, yeah, it is disabled. Okay. Okay, I have disabled Copilot. Let's check. No, it is not being disabled. I don't know what happened, but it's okay. What we'll do is delete Copilot for now. Okay, I guess that should work. And yeah, let me go here. I'll close this, and now it should not work. Okay, now that our Copilot is fully disabled, what I was going to do is like code this myself so you wouldn't have any doubts like I don't know the stuff and all. Okay, so now we have disabled our Copilot completely, and let's work on this app. So the three things for this app we are going to need is like, let's come here at first and let's check. For this model, we're going to use sklearn, that is not needed. We will use pickle to load the model, and numpy and pandas. Okay, pandas also we will not need, because in this situation we are not going to use pandas to predict. We used pandas to work with the data and not predict it. Okay, I hope you all understand. So let's import the necessary libs. Okay, so what are the libraries we are going to need? So import, we are going to need numpy, so let's import numpy as np, and then lastly we will import pickle to load our model, and last but not the least we'll import Streamlit. I hope you have understood why we did that. Okay, so now let's start with loading the model. Let's load the pre-trained model. So now what we are going to do is define loaded model variable, and let's store our model in that. Loaded model is equals to pickle.load, and let's open okay, so let's open the trained. As you can see in our file tree, it is saved as the trained model.sav. Firstly, this file was not there. This file came when we ran the cell in the Jupyter notebook. Let me show you the cell. Okay, when we dumped our model using pickle, the classifier, it got saved as the file name, and what the file name was, trained model.sav, whatever you call it. Okay, so I hope you have understood why it got there. I have not cheated anything. Okay, so let's load our trained model.sav as a read binary. It is a read binary. Okay, and let's create. Now we will start by making a prediction function. Whenever user passes a string, that function will be called on that string, and we will be good to go. Okay, let's create a function to predict the disease based on user input. Okay, let's do def prediction. Let's name it dia_prediction. Okay, and let's get it the input data. We will define that data later on. Now, what were the steps? Getting the input, converting that input into a numpy array, converting that array, reshaping that array as a column, then lastly predicting using the predict function. Same thing we are going to do here. Nothing is going to change. Likewise, we are not going to just define that tuple, but we are going to take the input data from the user. That will be done by Streamlit. Don't worry, I'll show you how. Okay, so now let's suppose that input data in this it is in the input data variable, this one. Okay, let's check change the input data to a numpy array. Okay, and then what we will do is input data, let's do input underscore data underscore array equals to np dot as array, and let's pass it the input data. Okay, so that data is now been converted as a numpy array in the function. So now let's reshape that data. So let's do input underscore data underscore reshaped equals to, and what we will pass, the input data array dot reshape, and what we will reshape it as 1, so what this will do is it will convert it into the columns. Okay, now let's predict the sentiment. Let's say sentiment. This is not sentiment, but still it's okay, it is the relevant word. Okay, so let's predict the sentiment using model's predict function. Okay, what did the predict function do? What did the predict function do? Generally took the input data, the reshaped one, and predicted. Okay, so and it will just get saved into the prediction variable. Okay, so input data reshaped, no, it is in the loaded model. Okay, the predict function of the loaded model, and what we will pass, the input data reshaped. Lastly, we will print the prediction, and now if the prediction is having the value 0 at its first index, I mean 0th index, we will return what? The person is not diabetic. Okay, simple as that. Otherwise, what we will do, else we will return the person has diabetes. Right, that's it. That's the whole function, and now we will create a main function. This main function will take every bit of parameter that our model needs. Now, for example, this model takes around 9 columns. Okay, what are those 9 columns? These: the pregnancies, glucose, blood pressure, BMI, diabetes, pedigree function values, age, etc. Now I'll just list down the 9 columns for you. That is pregnancies, glucose, blood pressure, skin thickness, then insulin, BMI, diabetes prediction function, that's its value, and the age. So in total it's 8. I'm sorry, I miscalculated. Okay, the model takes in total of 8 parameters. Those parameters are pregnancies, glucose, blood pressure, skin thickness, then insulin, BMI, the pedigree functions value, and the age. Okay, so let's train our model onto that, and let's make a main function to work with Streamlit. So let's define a def main. It is a good practice to get a 2-line gap. Okay, in the main function, let's get it a title using Streamlit. Okay, so let's give it a title. What should be the title? So st.title should be diabetes prediction web app. Okay. After this, what we will do, we will take the input values from the user. Okay. So let's get the input values from the user. Okay, now let's define everything. Pregnancies equals to, now this Streamlit has a function called as st.text underscore input, and we will give the heading to that column as number of pregnancies. Okay, I hope I spelled it correctly. Pregnancy, yep. Okay, let's input Streamlit as st. Okay, so it should work now. Now let's take glucose equals to st dot. As you can see, we have many functions. I didn't specify the alias at first, so that's why it was not coming, but it's okay. Okay, so let's take again text input, and what we'll get, the glucose level. Okay, thirdly, we'll take the blood pressure as st.text input again, as the blood pressure value, and again we will take the skin thickness. We will take the skin thickness value, same, and again we are going to do the same with the insulin value. So what does insulin do? Okay, insulin. So after insulin, we are going to take the BMI, and let's take the BMI value. After BMI, what we are going to take is the diabetes pedigree. I think that is called as pedigree or pedigree. I don't know. I think it's pedigree. I should do it. Pedigree function value, and I'll just say diabetes pedigree function DPF value. Okay, that should do it. And lastly, we have, I think, age. Yeah, and let's do age of the person this time. Okay, so those are all the values taken from the user, and now what we will do is code the prediction function. Not like we have already done it. We will just do a, what do you say, we will just do a calling a prediction. We'll just call it basically we'll just call it. Okay, so now let's do a code for prediction. Okay, and let's do diagnosis equal to, and let's take it as an empty string. Why? Because we're going to return a string. That's why. If it could have a number, we would have given it a placeholder number or something like that. Okay, so basically a string is mostly okay. If not, depends on the person. Okay, and depends on you actually, how you wanna treat your values and all. Lastly, what we will do is we will do st.button. We are going to do a button thing, right? Because after the last value of the age, like the age values inputted, we are going to take a button for test the result or view the result or something like that. Okay, so let's take test the result, or let's say check the result. Okay, now if that button returns success, that if that button is pressed, what we will do is we will store the diagnosis using the prediction function. Okay, so we will just call this prediction function control C, control V, so we have prediction, and what we'll pass, we will pass these values as an array. Okay, as a list. It will convert it to numpy array, and then things happen. Okay, so what were the values? Pregnancies, comma, glucose, comma, and they should be in the order that your model is trained. Okay, but now my model was trained in this order, so I took this in this order, because if you do not do that, and if any value gets switched, it might cause an error to your model also and your app also, depends on it. Okay, so after glucose we have blood pressure, not the blocking error, the blood pressure. Then we have skin thickness, then we have insulin, then we have BMI, then we have diabetes prediction function, and then lastly we have age. Okay, now after this function, let's check for success of the diagnosis. Like if diagnosis exists, it will show it to the user. So st dot, so let's show the result to the user. Okay, now what we will do, st dot success, and what we are going to call for diagnosis. If diagnosis exists, we will just call it. Okay, and lastly we will call the main function, because all of this is stored in the main function. And what are the norms of calling the main function? We will call if name equals main. Obviously it is a great norm of calling main functions as this, because this allows us to run the app using the terminal as a standalone file, you may call it. And let's call the main function. Okay, so if name underscore name, that's random method. What the random method does is it defines some kind of behavior of the app, and if that random method returns main underscore main, again if that app is being run using a terminal or as a standalone file, it will return. Okay, so that should be a pretty good explanation of what this does, and I hope you guys have done this tutorial till here. Okay, so now what we'll do is we will save the file, open a new terminal. Okay, after opening a new terminal, what we will do is Streamlit run. This runs a file. Okay, this allows us to run an app. So now what we will do is we will generally just call this function, call this using the terminal. So Streamlit run, my file name has spaces, so I have given double colon, and I'll just do that. So diabetes prediction webapp.py. If your file name doesn't have spaces, you can directly add it without these double inverted commas. Okay, so if we run, it should run. Yeah. So as you can see, the UI of this app is great, actually great, to be honest, because an app being this good by writing how many 53 lines of code, that too takes like so much like blank lines and all. Okay, so that too while taking this much into the, what do you say, into the file. Okay, so as you can see, by just taking 53 lines of code, that too taking some blank lines between those, it's not even 53, it's less than that, because those lines contain comments and all. Only using these 8 lines, we have created these 8 things. And yeah, if we just go to the file, okay, let's, oh wait, you might not be able to see this. Okay, my bad. Okay, wait. I'll just deploy this again. Okay, and if I do this, okay, the stream has stopped now because I have cleared the terminal. Okay, so my bad, my OBS software was not configured to take the browser window, my bad. Okay, so if we do Streamlit, run, and lastly we will pass the name of the file, so diabetes prediction webapp.py, and hit enter. As you can see, the app has run, and getting 9 and 10 lines of the app, like just writing 10 lines to get an app looking this much good is not a joke. Actually, it saves much more time that you ever think, because you'll get more time to train your models, to focus on your models, and then literally just deploy them in 10 lines of code. Yeah. What is this? Nothing. Just focus on building your apps, like building your models, and lastly just deploy them using 10 lines of code. That's it. That should be done using Streamlit. And it is not like it only takes certain text input and all. If you do st dot, you just have everything. You have the audio inputs, the balloons, the bar charts, and so much. Actually, we also have video, I think. Yeah, see, we also have video. So Streamlit takes care of everything that you need for your app, for your web app to be precise. And now if we just to come here in the, what do I say, the Colab notebook or Jupyter notebook, you say, and do 5, 166, 72, let's do 5, 66, 72, and then go to code again. Okay, 166, 19, 175, and 25, 19, 175, 25, and what's the DPF? Okay, 25.8, then 0.58751. Okay, 25.8, this, P1, and here it was 0. And if we do check the result, the person has the diabetes. And if you check here, the result was 1. That's why the person has a diabetes. Okay, the person is diabetic. Also, a Streamlit app does the same. Now, if you come here, you can see the deploy button, and if you just click on deploy now, you can deploy the app for the community to the Streamlit community cloud. That cloud consists of models developed by other people. Also, you can deploy unlimited public apps for free, and then the apps are discoverable through Streamlit Gallery and also the search engines. As I said, your app will be visible to the recruiters through search engines as well as some gallery, like some gallery URL or something else, or likely the search engine URL. And that's it. And you can also custom deploy using some hardware like GPUs and a VM, or using an EC2 instance on AWS using Docker or Kubernetes, etc. etc. Okay, so I hope you have enjoyed this video, and make sure you hit the like button and subscribe to the channel. I hope you have enjoyed, and I'll see you guys in the next one. So this is Atharva from Pi Analytics, and peace out.